Next, we're going to look into that comparing the population mean for the case it is equal but unknown population standard deviation. Okay, so as we know that the equal and unknown population standard deviations, and we're going to use that the pool t test. Okay, we're going to use that the pool t test. Okay, so in the pool t test, which means we do not know the population standard deviation. So in that case, we have to use the pooled t-test. Okay, let's see how the procedures and how should carry out in order to do the analysis. Okay, so the learning outcome for this particular topics is that we do the test hypothesis for the two independent population with that means are equal with unknown population standard deviations. Okay, all right. So as we know, the t distribution is used as the test statistic if one or more of the sample have the less than 30 observation. Okay, so if anything, the sample which is less than 30 observation, then we are suggested to use the test statistic. Okay. All right, the required assumptions, you should know first that both population, okay, must follow the normal distribution. Okay, the population for the two sample set data must follow that normal distribution. Next, the population must have equal standard deviation. Okay, the population must have that equal standard deviation. Okay, so if not equal, then we cannot do. We must should have that two standard deviation. And then the sample are from the independent population. So these are the condition when we carry out the pool t test. Okay, once you identify the condition or the assumption, so next that finding value t tests are required two steps. Okay, they just involve a two step. First, you need to calculate the sample standard deviation or pool that sample standard deviation. We have the formula on that. So once you just calculate the pool, the sample, the sample standard deviation, then you need to calculate pool standard deviations to compute the t statistic. Okay, you need to use the pool standard deviation, the what we have here. Okay, and then use this value. Okay, this value, and then in order to calculate that, the t statistics. Okay, so we'll see that what the formulas are. So for the pool, the sample standard deviation, we have the formula as variance square. Okay, this is the statements for the given for the pool. Okay, equal to n1 minus 1. Okay, in bracket s1 square. Okay, this is for the variance for the sample 1 plus n2. So n2 means that for the set sample 2 minus 1, this is the variance for the sample variance of the sample 2 over n1 plus n2 minus 2. So this is the correction area. So what you should have done, because usually if we want, we just use n minus 1, right? Okay. So since we write is we consider two independent set of data, so we have to write it in this way. So 1 plus n2 equal to 2. So which means this is in order to calculate the sample standard deviation. Next, the pool standard deviation to compute the t-test. So we just write that the t-test formula, the t equal to mean sample 1 minus mean sample 2 over square root of the variance square of pool, the one you obtain here. We need to substitute here. So in bracket 1 over n1 plus 1 over n2. So mean sample 1, number of size of sample 1 or size of plus size of sample 2. So then you can able to compute that the T value. Okay, so these are the procedures. So memorize this formula and this formula. Okay, all right, next. Take a look at this example. All right, so this is for the case when we unknown the population standard deviation. So how are we going to use this formula in order to obtain a solution? The question is there, okay, is there a difference in the mean time to mount? Okay, so they want to find out, is that this is a question, is there, the same thing goes to your group assignment. Okay, is the question is similar, is there a difference in meantime mount the engines on that the frame of the lawnmower? So these are the questions you need to know. All right, so you should know that what are the keywords in this question. Is there a difference? So difference, automatically you know that you should that equal. There is no greater or equal. Okay. All right. So they want you to calculate, is there the difference in the mean time mount in the engine on that the frames of that lawnmower. Okay. So that all you need to know. Okay. All right. Now, the first procedures was developed, the long time owners employee herbs was designed by that. Okay, so you initial with the W. Okay, the first procedures was developed by the long time owned employer herbs, and then the other procedures was developed by the owner vice presidents engineers Williams. So they designed it by A. Okay, to evaluate the two method, it was decided to conduct a time and motion studies. Okay, so now a sample of 5 employees was timed using the Wallace method and 6 using Atkins method. Okay, so uh, so 5 employees using that the Wallace method and 6 using that Atkins method. The result in minutes, okay, they shown here. Okay, so this is a number of sample, number of people. They 5 and this is 6. Okay, the result in minutes they shown on the right. So it's here. This is the result. Is there a difference in the mean mounting times? Okay, is there difference in the mean mounting times? Use the 0.1 significant level. So I mean the 10%. Okay, so significant level or level of significance is at 10%. Okay, all right. As we know, we have the information on the table here. Okay, so this is the minutes is given for the 5 employees tested, and based on the Wallace method, and for the Atkins method, the 6 employees is they use to check on that how long does it takes for that time for that. Okay, what they going to test? For the mean mounting times. So the mean mounting times, so this is given the 3 minutes, 7 minutes, 5 minutes, 8 minutes, and 4 minutes, and 3 minutes. So this is that the 6 employees, they test based on that Atkins methods. Okay, and as well goes to the Wallace method. Now we're going to develop that the procedures in order to do the statistical analysis. Step 1, so we should know that the state the null and the alternate hypothesis. That's the first thing you have to know. All right, the main things, this now I show you, right, is that a difference, okay, is the difference. So you should only use that the equal or not equal, okay, so that's the keywords. If the greater or equal, then the question, they will tell you whether it's more or less, something like that. So is there a difference? So then you need to write in this way. Okay, now with this the hypothesis null, we just write down first. So we're going to prove that it's not equal. Okay, so hypothesis null, the mean mounting times for the Wallace method is not equal to that the mean mounting time for that Enkin methods. This is what we're going to discuss. So that the null hypothesis, so we just write as equal. So that means that mean mounting time for the Wallace method is equal to the mean mounting time for the Enkin method. Okay, so that the first start we need to write down the statements for the hypothesis null and hypothesis alternative. Second, you need to determine that the significant level, as we know the significant level is a 10% is given. Third, you need to select that appropriate t-test or appropriate test statistics. Okay, so as we know for this case, the number of sample is less than 30. Okay, so so you need to should go for the full t-test. So in other words, because the population standard deviation are not known. Okay, so one thing is we do not know that the population standard deviation, okay, is not given in the questions. Okay, so is assumed to be equal. Okay, we assume to be equal, and we use that the pool t-test for this case. Okay, all right. Now, once you've done that, the step 4, you need to state that the decision rules. Okay, so the decision rules, we reject that hypothesis null if the t value that obtained from that the table, okay, in the calculation, the t distribution value, if it is greater than that the critical value is given at 10%. Okay, so t alpha, because this is equal, right? So equal, this means we have to consider both sides. So the alpha value must be divided by 2. So you need to look for the two tails. Okay, so this side and this side. So the statement we written in this way. So t alpha divided by 2. So this is your n w Wallace method plus n a number of sample of the Enkin methods minus 2. Or we can write this way. Okay, or the t is less than minus t, okay, alpha over 2 nw plus na minus 2. Okay, so we simplify it based on the information we have. So t greater than t 0.05, 9. So this is a number of sample because we take that 11 minus 2, we get a 9. Or if the t less than, the same things on the left hand side. Okay, all right, or we just, okay, once we've done that, we look at the critical value in the table. So the t is we obtain is 1.833, or so okay, the t value is 1.833. This is a critical value at this point. We can say the alpha. And then this side is a t alpha is given is minus 1.833. Okay, from the left hand side. So this is your center. Okay, now, so we draw that the table just now. All right, so we already know that the critical regions here, okay, and critical region here. So now we're going to do that test. Okay, we're going to compute the t value. Okay, and we're going to make a decision. So using t formulas, okay, so we're going to calculate that the Wallace method and Enkin methods. So first thing, what we're going to do, we take that the difference between the mean, okay, for each values, all right, each entries of that the x minus with that the mean of the w or mean of Wallace. So we get the result. So you need to get the square. So we just add up all, you get 34. Same things for the Enkin methods, we just list down. All right, so you need to find the difference from that each corresponding samples or the minutes minus with the mean value of the Nkin, the mean value of the Nkin, and then square, and then you need to get the value and add up and find the sum of it. Okay. All right. So this is how you need to get. So first thing is get the mean value of the values. We got a 4. Okay. So how you get it? Just using this method. All right. For the mean value. All right. And then again for the Atkin mean, so you just get that the same things. Okay. 30/6. Okay. So we got a 5. And then we look for the standard deviation for the values. So we got a 2.9155. So use this as formulas. I'm sure you all know about it. And then for the standard deviation for the Nkin, all right. So use the sample information, the value that we have, and then we substitute into the standard deviation formulas, and we get the sample standard deviation for the Nkin method is 2.0976. Okay. Now, once you just identify all this value, the mean and standard deviation for the samples, now we're going to calculate the pool sample standard deviation. All right, that's the formulas. First, we need to calculate the pool sample standard deviation. You get a 6.2222. So that means the pool sample deviation, all right, okay, between the two set of data is 6.2222. Okay. Next, we're going to use the T statistic. Okay. So you need to determine the T value. Okay. So once we just get the T value, then we're able to make a decision. All right. The T is equal to, as we know, formulas are given. I showed you just now. So you just substitute the mean value of the values and Ankin method. So 4 minus 5 over square root of 6.2222. This is the pool standard deviation. And then multiply by 1 over standard deviation. So number of sample for that set 1 is 5 plus 1 over the number of size sample for that set 2, which is 6. So you get the T value is minus 0.662. Okay, what does it mean? What does it mean? Is this greater than the critical value of the T or less than the critical T? Okay, we check on that somewhere here. Okay. So if you see the minus 0.662, okay. So if you compare this region, okay, so this region is the minus 1.88, sorry, 1.833. So since that minus 0.662 is fall in this region, okay, okay, so that means we should not can say that we not to reject that null hypothesis, okay, because it's fall in that non-rejection region. So which means here, okay, if it is less than minus 1.88, if it is fall this region, then you need to reject the hypothesis now. Since if it is not fall in this region, if we fall in this region, then we accept, or that means we reject. We not to reject the hypothesis. No. Okay. So you need to know that clearly, that identify, okay, where it is false exactly, then how we going to make a decision. Okay, the interpretation, you can do that. You can say that the data show no evidence. Mean times to mount the engine on the frame between the Wallace and Atkin methods. Okay, so no evidence, which means we don't have any proof in order to reject that the null hypothesis. Okay, so that is the interpretation.